Okay, so in this lecture I am going to be going over a circuit problem, and the circuit problem is to find the node voltages and the power of each source in this circuit. So I have VA, VB, and VC here, and I have a 9-volt voltage source here and a 1 amp current source here. Okay, so for circuit analysis, VC minus VB equals 9. That's an automatic constraint, as you can see from the schematic. VC minus VB, that gives you 9. Okay, so VC minus VB equals 9. And then so you have VC equals 9 plus VB. That's equation number 1. Okay, so then next you have KCL at VA. And so that gives you 1 plus VA minus VB over 10 plus VA minus VC over 2 equals 0. Then next, VA over 10 minus VB over 10 plus VA over 2 minus VC over 2 equals negative 1. Then next, we have 3VA over 5 minus VB over 10 minus VC over 2 equals negative 1, and that is our equation number 2. Then next I'm going to take equation 1 and put it into equation 2. And now that gives us 3VA over 5 minus VB over 10 minus 9 plus VB over 2 equals negative 1. Then next I have 3VA over 5 minus VB over 10 minus 9 over 2 minus VB over 2 equals negative 1. And then next I have 3VA over 5 minus 3VB over 5 equals 7 over 2. And then finally I have 6VA minus 6VB equals 35 for equation number 3. Okay, so next, KCL at the supernode of VB and VC. So we have a supernode at VB and VC. And so what we have is VB minus VA over 10 plus VB over 3 plus VC minus VA over 2 plus VC over 20 equals 0. Next, I have VB over 10 minus VA over 10 plus VB over 3 plus VC over 2 minus VA over 2 plus VC over 20 equals 0. And then finally I have negative 3VA over 5 plus 13VB over 30 plus 11 VC over 20 equals 0. That's going to be equation 4. Okay, so next I have equation 1 going into equation 4. And what that produces is negative 3VA over 5 plus 13VB over 30 plus 11 times 9 plus VB over 20 equals 0. Then next that gives me negative 3VA over 5 plus 13VB over 30 plus 99 over 20 plus 11VB over 20 equals 0. And then next I have negative 3VA over 5 plus 59VB over 60 equals negative 99 over 20. Then next I have negative 36VA plus 59VB equals negative 297. And then finally I have 36VA minus 59VB equals 297. That is my equation number 5. Okay, so next what we have is 2 equations and 2 unknowns so far. And using equation 3 and equation 5, the system is A equals a matrix of 6, negative 6, 36, negative 59. And B equals a vector of 35 and 297. V equals a vector of VA and VB. And so V equals the inverse of A times B. And so next we can move on to our final result. And we have that VA equals 283 over 138, which is approximately equal to 2.05. VB equals negative 87 over 23, which is approximately equal to negative 3.78. And VC equals 9 plus VB, which equals 120 over 23, which is approximately equal to 5.22. Now, the power of the current source. Voltage of the current source is the same as the voltage at VA. So VA equals 2.05, and the voltage indicates lower potential at the arrowhead of the current source. This means the source is absorbing power and has a positive sign. So therefore, the power of that 1 amp current source equals plus I of 1 amp V of 1 amp, which equals plus 1 times 2.05, which equals plus 2.05 watts. And so it is absorbing power. Now the power of the voltage source. So the currents at VC, at node VC, we have I of 20 ohms plus I of 2 ohms plus I of 9 volts equals 0. And so next we have VC over 20 plus VC minus VA over 2 plus I of 9 volts equals 0. And so next we have 5.22 over 20 plus 5.22 minus 2.05 over 2 plus I of 9 volt equal 0. And so then next we have 0.26 plus 1.59 plus I of 9 volt equals 0. And then next we have 1.85 plus I of 9 volt equals 0. And so I of 9 volt equals negative 1.85. This current is negative, meaning that it enters node VC. This means that it comes out of the positive terminal of the 9-volt source. So the source is delivering power and has a negative sign. The power of the 9-volt voltage source here equals negative I of 9 volt times V of 9 volt equals negative 1.85 times 9, which is approximately equal to negative 16.65 watts. So again, it is delivering power, this 9-volt source. Okay, so simulation results. It's a good idea to check this over with some simulation results. And what I have here for the power of the current source is 2.05072. For the power of the voltage source, I have negative 16.59783. For VA, I have 2.05072. For VB, I have negative 3.78261. And for VC, I have 5.21739. And so about some approximation accuracy here. Okay, so for the power of the voltage source, the simulation indicated 16.59783 watts. The calculation indicated 16.65 watts. And so if you calculate the percentage of a difference between the two, you get that your calculation here is 0.31% higher than the simulator result, which is less than 1% higher, so the accuracy is good. So that is all that I have in these lecture slides. Hopefully it was helpful for you. Thank you for watching, and have a nice day.